Welcome, everybody. We're going to get started with our webinar today. Welcome to Tech Talk Tuesday with Baseline. I'm Dan Conger, Baseline's training manager. I'm the host today. Andy and Chris are both out on vacation at the same time, so we can do whatever we want, Lisa.
Yay! But it's recorded, so.
Okay. Well, that's true. They'll see the recording. Okay.
Dang it.
Lisa Rienstra, our RSM for the Southwest, is here talking with us today. Thanks for joining us. We're going to talk about a site in the Southwest that we're going to get into some details in. But before we do that, I think this is always a good time to remind you that the recordings from the show and lots of helpful videos are available on YouTube at Baseline Web Training, all one word smashed together. You'll find all the Tech Talks from season 1, season 2, tutorial videos. I got another round of tutorial videos I'm working on. That'll come out probably later this week. So definitely check that out. Check the recording. Okay. So Lisa, tell us about, I'll share my screen, but I want you to lead us in with what kind of site is this and tell us a little bit give us some background history on this.
Okay, so yeah, the picture you're looking at is actually the Clubhouse, which is the Clubhouse at around 800 acre development in Arizona. So master plan development, and we started designing this in about 215, 216, and started installing 217, and so for the infrastructure of the development, and the contractor probably wrapped up the install around 2019.
So I wanted to point out a few things that may not be, that aren't unique to me, because I live in the Southwest as well. I don't live in Arizona. I live in Southern California, but these are things that I'm used to, but maybe not people in the Midwest or the East, is just looking at the plant material, right? So this is pretty typical of Arizona, New Mexico plantings. So we've got a lot of rock mulches, not ground cover plant material. Looks like there's some shrubs that will spread and cover. Definitely drought tolerant trees. Palo Verdes, I think, very small leaves. They're very resistant to drought. Everything's on drip. And then the turf, the high water use things, very consolidated areas at the Clubhouse, right? We won't see turf at monuments or entries in Arizona ever. Well,
correct. Well, not ever, but
yeah.
in the outer desert areas. How's that?
There we go. Yeah. And certainly the newer places, you won't see them, right?
Yeah. Yes,
absolutely. Right. So this is the Clubhouse for the community. It's pretty nice. I had some pictures that I got from Google as well. Of the swimming pool looked gorgeous as well. So yeah. So pretty typical that what we're seeing here. And then, so this looks like a typical streetscape there.
Mm-hmm.
And what I was catching my eye, and something that I remember I really noticed in Arizona, first time I visited eons ago, was the amount of swales and stormwater movement that they have. So you can see there's a very pronounced swell between the sidewalk and that block wall. Because I think it's mainly in your summer monsoon, you get some pretty heavy rains. I mean,
they had the other week 3 inches in a day, in some of the areas throughout the valley. So it was pretty brutal.
That's impressive. That's impressive to get, 3 inches of rain in a day for some heavy and compacted soil. So yeah, definitely being able to move it, not flood houses. So
yeah.
Okay. And then here was one of the playgrounds in the community, just a little bit of turf, and this is probably as green as the landscape's ever going to get, right around
it's probably a winter, because you can see the grasses, the fountain grass or whatever kind of grass they use there is deciduous, so they haven't cut it back yet. Looks like
yeah, right. Okay, beautiful. And then the other thing that you're going to see in the Southwest is shade structures over play equipment.
Yeah.
When I was a kid,
necessary.
had those metal slides that would just burn the skin right off the back of your legs when you're 5 years old. So
yeah,
beautiful. Okay, so that's kind of an overview of the community. We've got nearly 800 acres that we're covering on this. Let's talk about. Oh, this is another really good picture. So of kind of the scope of the project. So this was kind of early in the process when I grabbed this image, but This is all pretty much rolled out now, isn't it? Is that accurate?
Yeah. So all those streets, the infrastructure was completed. And then of course, a lot of homes, it's probably 3/4 of the way built out by now, if not close to 100%, I'd imagine. It's been going on for a while.
Sure.
So just the satellite images haven't caught up.
Right. Okay. Yeah. So it's definitely got a large scope on it. And I suspect that eyeball shaped saying slightly center right. I bet that's the community clubhouse, and it kind of looks like an open space area, not going to be too dense with housing.
Right.
Okay.
But just kind of, you can see the main artery that kind of we should go through, kind of ends because it's not. But yeah, it's right there on the lower right hand portion.
Good deal. Okay, and then a couple of natural drainages or water. I don't want to say waterways because that's going to imply there's a creek there, but a seasonal creek or seasonal drainage through there.
Yes, true. That's actually they left that as native for sure. The wash.
Okay, good deal. Okay, so here's what I think I got a pretty good record of what finally was on the final build out, what was in there. So you want to walk us through the hardware that's in the ground there?
Yeah, so we have 6 base station 3200 pedestals. This is the final build out, right? We have 1 wall mount substation, 1 pedestal mount actually flow station, but that's okay. I don't think we have too many images of those, but a flow station. We actually have 7 cloud networking modules, 19 master valves and flow sensors, and about 1,000 zones out there. Okay,
so let's back up to the flow station, because you mentioned that one. The flow station, actually, I have a picture of a cabinet, but what actually happened in this one is the flow station is actually mounted in the base of one of the pedestals, so it saved a pedestal installation. So excellent.
Correct.
Okay, so let's unpack this for a second. Over 1,000 zones and 6 controllers. So I'm not a good math wizard, but that's fewer than 200 zones. Well, 6 times 200 is 1,200 zones. So it's just under 200 zones per controller, or there might be one with 200 and another with 120 or something like that.
Right. One 179, one 190, you name it. Yeah.
Yeah, exactly. So I think we gotta appreciate and recognize that you're able to water 800 acres. Now, granted, it's Southwest planting, right? It's not dense like we might have in other places, but you're able to water 800 acres with 6 controllers.
Yeah.
Damn. That's
very efficient use of equipment.
Yeah.
And capabilities.
Because from my contracting days, I had 40 acres and 20 controllers.
12 stations here.
Yeah, exactly.
24 there. Maybe you're stretching at 24.
So the two things are going for you is a station count, and then the 2-wire, right? Those are 2 things that allow that to happen, right? You can really run further with 2-wire, but to have only 6 controller interfaces, but then able to bring those together with base manager, that's the management on this is going to be, you could really get down to that nitty gritty on managing water on this site, which they're going to need to do on a property like this.
Yeah.
Okay.
Absolutely.
Okay. So then here's the hardware that actually went in. But let's talk about the design process and their design intent. So what was from the designer's perspective, which sounds like you were involved with that pretty early, what was their goals and what was some of their intent?
Yeah, his goal was really to maximize the capacity of our controllers and minimize the amount of equipment out there to make it a simple site to manage, right? Take advantage of multiple meters per controller. So if you kind of look at maybe controller D, which is green, right? And look at the green striping, he's got 1, 2 in that. But if you look at controller F, it's got 3, right? Whereas controller C's got 2. And so like if you go down to controller, let's see, I guess B, it has 2. So they all have 2 to 3 control points per controller.
So it's not the old school 1 controller per water meter, 1 controller per master valve. It's not that. They're using 2, sometimes 3 water sources per controller. And just to remind everybody that, base station 3200 can handle 8 different water sources. So 3 is no big deal. So that's cool. So definitely
right.
can handle.
Really tried maxing out the, so it was that, and really what maxed it out was the zone count. And so really balancing that and making sense of it, which he did a great job at.
Yeah, that would seem like that would be an interesting design aspect, is to maximize the station count for a controller, but not be crazy with catching the 4 zones that happen to be on the other side of the property. Make sure that there's a reference to the current controller, and that makes sense to be there.
Right. While keeping with the wire run lengths and, whatever his, concurrencies needed to be, right? Because your gauge and your wire run length and quantity will affect, and how many your loads of zones will affect how many you can run at a time.
Right. Yeah, that's true. Right. So there's a few pieces on the design process to juggle there. I could imagine that. So
I think he might have had 5 and added 1 more at one time, but he definitely did a good job at maximizing it.
So that sounds like their process there. And then I'm going to assume having something that's, not too difficult for someone to manage in the future, but also have lots of capabilities, right? So there's that balance there between ease of management, but having, a very capable system.
Mm-hmm. Right. And like D was a gated portion of the rest of the development too. So that was kind of unique, so he made sure to keep that with one controller in that lot. So, yeah.
So that's behind a gate, you said?
Mm-hmm. Mm-hmm.
Oh, okay. Oh, yeah. Right.
That green portion. Mm-hmm.
Right. So it make it challenging to get, or harder to get into. Okay. Mm-hmm. So here's what I think this is pretty close to what they intended to put in the hardware. So that when you in your design process, this is the hardware that you'd planned on. So let's talk. Why don't you walk us through that?
Right. So originally he designed the 63200s, and we were going to do an Ethernet radio to the clubhouse that you guys saw. At the clubhouse would be another radio. It's Ethernet hub that the GC would connect directly into Ethernet at the clubhouse to go to the web. Okay.
And then the same flow sensors and master valves and the same zone count, roughly the same zone count. Mm-hmm. So with the radios, then, just as a reminder for everybody, Ethernet radios don't connect directly to the internet, but they allow a digital TCP/IP communication between devices. But then we need a single connection, or they were going to plan on a single connection to an internet and share that via radio. So that was where the Ethernet hub would be, the single point connecting, probably with an Ethernet cable.
Yes.
Could
be a cell, but in this case, it was going to be Ethernet at the supply desk. Yeah.
Okay. So this was what the hardware that you talked with them 4 years ago about. This took a while on this project. It's impressive.
Yeah. It was before we did some other capabilities, right?
Right. So, okay. So let's compare that against the final build out. There's some differences here, right? So we've got the same controllers, the same flow sensors, the same zones, but the substation wasn't on the original list. So high level, why did they use the substation? Why did they want that?
Was one of those things further into, as they were doing their final drawings, they threw in an extra parcel that wasn't originally included in the design. So it didn't have a lot of zones, but just had a meter. So if you see in this picture right here, that A1, there's the little parcel and the meter, or maybe even a couple meters. So they were able to, because we had enough zone count left over, and one of the other controllers, we were able to add a substation last minute and pick up those zones and those control points, and they are now part of E.
So A1 substation came into a controller that wasn't full up to 200 zones, and it was a reasonably economical decision to bring those wires in. Okay, so basically, relatively last minute, they added a phase or a subphase, and you brought it in. That sounds like a perfectly good reason to bring in a substation, and actually a pretty smart choice to do it.
Right. So especially since things were under construction, right? So have to try to now figure out where to run the wire. Now you can just, run your own new wire in that little parcel and not worry about connecting it directly to E.
Nice. Okay. So the flow station is something that this one threw me for a moment when you told me that you had a flow station in the final build out. So I'm gonna tell everybody why I was confused, because so a flow station is there to manage flow and water sources amongst multiple 3200 controllers. Well, we already established that a base station 3200 can handle 8 water sources, and you only had 3 water sources. Why would you need a flow station to manage flow amongst multiple base station 3200s or water resources?
Yeah, construction never goes as we all want, right? Sometimes mistakes happen. It's not the first time for us, and not the last time that it happens, especially in something that's complex, right? I mean, that's a very large site. That contractor that was awarded that entire job, man, they were spread thin. So unfortunately, they ran the wire to a master valve to the wrong controller.
So instead of connecting it to D, they connected the wire to F. The master valve is residing in D. Damn. That could be really brutal, because between D and F, there could be a quarter mile or a half a mile of completed master association landscape.
Yeah, everything's paved, everything is done.
And there's a road crossing too, right? Because those sleeves are buried nice and deep. That would have been ugly. So how'd the flow station fix that?
So the flow station is able to obviously share flow between, different water sources. So we're able to assign via the flow station that master valve in all reality back to F and correlate it to those corresponding zones and mainline that they reside on. Yeah. And very short term, simplification there. But it was great because it was no problem. Sure. I've had this happen at another site right before that as well. And it's great that we're able to actually do something with the flow station, whereas nobody else really can solve that problem. They would just be SOL, really. True. And nobody would make them run that wire. The maintenance company would have a nightmare on their hands to maintain that. Because
your other choice would be to leave one of those master valves always open and basically bypass the master valve. Yeah. And then the flow sensor. Now you wouldn't have flow data too.
Right.
Yeah. So a question came in from Don, and this is actually kind of appropriate. This is an appropriate time to answer it. Is what is the name of this project? And we specifically didn't say the name of the project, did we?
Right.
We're being not. We being nice to.
It's not a big deal.
Yeah. Well, you can tell them individually, but we're not going to say it on air. We're being nice to the developer, but also we want to be nice to the contractor, right? We don't want to throw anyone into the bus. And I think to your point that you said earlier, this kind of crap happens. It's unfortunate, right? We want things to go perfectly. They don't always. And this was actually a pretty good solution to a snafu.
Yeah, absolutely. It's awesome that we're able to provide a solution very economically too.
Right. Because again, this went in the pedestal base. So it didn't need an entirely new pedestal, didn't need a new cabinet. It just needed to communicate with a couple of devices. So excellent. Okay. So actually that kind of brings us up to communication. So this is also different on the final build out. We had cloud network modules, but in your design intent, you had Ethernet radio modules. So why the count on modules was a little different, and you switched from radio. Well, first of all, why just switch from radio to cloud?
So the good thing that happened over the couple of years of this build out, while the installer was installing, is we came up with our IoT, our IoT network, right, and our cloud networking modules. So we're able to communicate cell to cell. As you know, you can't site survey dirt, flat land.
You mean like this one? So exactly. Yeah. So a site survey on this one, a radio site survey, or to qualify a site with dirt, you could, because this will qualify. Like this works great. Yeah. This is perfect. There's
nothing in the way.
Except this is the reality, right? We've got 2-story houses, block walls, vegetation. So this is a challenge with radio. So on sites like this that are built out like this, how do you make radio work on sites like this?
Yeah, so you either have to add your, what you do is you add your antennas and posts and have to go up and literally get, your radios to work in between houses. So you typically have kind of eyesore antennas hoisted above the canopy line or between homes.
Mm-hmm.
So what happened here is, fortunately, with the advent of the IoT server, we were able to just go to cell modems and ditch the radios, and they all could communicate via our IoT server instead of having to have, and with their salt shakers, instead of having to have the expensive radio equipment.
Right. So if you look at the picture of the flow station and the substation, I've got a salt shaker antenna on there, and you were able to do that all with the small salt shaker antennas.
Right. No site survey needed. They all go and network with our cloud and base manager.
So if you're in an area that has good cell coverage, cell, and remembering that cell works different, cell radio waves are different than Ethernet radio waves. It could actually get you out of a jam and shorten your antennas. Well, the other one that we talked about pre-show was when you get these long masts, these tall masts, or you need to move them out of the way, now you need to run cable and you need connectors and you need to make sure those are waterproof. And then every foot of cable adds some noise to your radio frequency. So yeah, I definitely see some of the advantages of the cloud network. And
no distance limitations, right? So actually, when I calculated it out with the substation too, because that was kind of in later, right? It went cell. Then the 3200s all went cell. We got rid of the gateway. Gateway's gone. There goes that cost. The install cost on radio is expensive too, because they need to add posts and a lot more labor and sweeps. So this really saved them a ton of money at the end of the day as well, and was just a much more efficient way to resolve all the problems and challenges.
And since we're talking about it, and we got a few minutes, we're actually doing pretty good on schedule. Is that let's talk about radio versus cloud network and cell. And so I know that you've looked at a couple projects where you've looked at a return on investment. So one thing about radio is you're buying the equipment up front, and there's no subscription, there's no recurring cost. Mm-hmm. Where with cloud network, you're buying the hardware up front, but there is a recurring subscription cost. Mm-hmm. So let's talk to me about the return on investment and when that pans out. What did you think?
Every site's a little different depending on how many modules you have out there, but typically we're seeing 10 to 15 ROI when you're looking at installation costs. In this case, sweeps weren't even put in the pedestals, so that would have been even more problematic and costly for the coax cable. Okay. So again, some of that does happen. Just not bashing on any contractor at all. It's not not the first, not the last, but definitely saved them some time, money, and were able to get in and out. And the maintenance contractor was able to really move along and take over everything on the web. So that was awesome. It was great resolution for them.
Okay. Well, we're getting close to the end of our time. I wanted to see if anybody had any questions for Lisa other than the secret name of the project. Yeah. What I'd like to do next week is kind of pick apart that substation, flow station, cloud network, kind of pick that apart and kind of talk making changes on the fly for spec projects, and maybe talk about some of the wiring, especially the wiring on that flow station thing, because that's kind of intriguing to how the solve on that one. So that's why today we're just kind of high level on that one.
Yeah, absolutely. No problem.
Well, cool. Any other big projects you got on your list? Because these are always fun.
Got some good master plans coming up, but hopefully they'll just keep moving forward. Okay. So,
and it's a really long term, right? 4+ years.
Yeah, all these are always pretty long build out. So, but it's fun to see them come to fruition. That's for sure.
Cool. Okay. Well, we're a few minutes early, but that's okay. We're gonna give you back your 5 minutes, and everybody else their 5 minutes. So I want to thank everybody for joining us today. And so you'll find this recording, if you missed this or for a previous, on Baseline Web Training at YouTube. The recording will be up there, and I'll have it up sometime this evening or tomorrow. We'll have the recording will be up there for you. And next week we'll be back at the same time. Chris and Andy should be joining us. If Chris is done with his vacation, then playing out and about. So, okay. Well, Lisa, thanks for your time today. We really appreciate you joining us.
Good being here. Thank you, guys.
Okay.
Ladies.
See y'all next week. Bye.